Hello, geometry. Here we go with lesson 4. We're going to be talking about vectors. I know a lot of you probably think of Despicable Me when you think of vectors. You can see right away. If you haven't seen the movie, this is going to make no sense. But if you have, you know that a vector has magnitude and direction. All right. And we're going to also look at component form, and we're going to take a vector in component form and find its magnitude and direction. So basically, we're going to go both ways with it. So just said it, but a vector is a quantity that has magnitude and direction. Okay. It has an initial point, which we call, I also just use starting point, and a terminal point or an ending point. So it stops. The distance from the starting point to the ending point is called the magnitude. So the magnitude is just its length. All right, the direction corresponds to the direction the arrow is pointing. A vector can be represented by a coordinate pair in the coordinate plane. This is called component form. Those are kind of the basics of vectors. All right. Scroll down a little bit. Pictorially, what you see here is it looks like a ray. That looks like that pink thing there looks like a ray, but it actually ends right there. It ends right there. Okay, so rays go on forever past L, but this one actually stops there. The magnitude of this vector here is 65. Now, there a lot of times there's a label on that. Sometimes there's not, but the magnitude is its length, and that's just 65. The direction is the tricky part for most people. This one's actually 50 degrees, but then you got to give, it's called cardinal directions. It's 50 degrees, and that's actually south of east. So south of east. All right, we'll talk about that in a little bit. The initial point is O. The terminal point is L. Component form for this one is X and then negative Y. Okay, so the point X and then negative Y, that's the component form. Again, we'll talk about that in a little bit as well. So give the direction of each vector shown here. The number part is very easy. It's 35 degrees, but now the hard part is the directions. And this one I will tell you is east of north. The next one is 25 degrees south of east. And the last one here is 20 degrees. And that one would be west of south. So how do you do this? So there is a little blue arrow on each of these, right? Well, not on this one, but I'll explain it in a little bit. The last letter you write is where you start. So you're going, you're starting it on the first one, you're starting at the north line, and you're going which direction? You're moving towards the east. So that you say which direction you're traveling first, and then you finish it up with where you started. So the first one, east, I'm traveling east of the north where I started. On the next one, I start on the east and I'm traveling south of where I started east. Okay. You'll get a chance to practice that a lot more with this, with the practice with this lesson. Describing a vector in component form. I'm gonna try and keep that so you can see the picture up above. Describe OL, which was up above, in component form. Give components to the nearest tenth. So I said XY, right? Or X negative Y. That negative is the hard part to remember, honestly. In this case, it's positive and negative because a point in that quadrant there has a positive x value and a negative y value. And what we're going to use, you might have been wondering why we're doing this when we just got done doing all this trig stuff. Here's where the trig comes into vectors. All right, so you see that we have a right triangle. I'm using the picture. If you can't see me annotating on this, got a right triangle right here. So I've got trig that I can use. I've got that 65, which is the hypotenuse. And I'm trying to find x, which is adjacent to that 50. So I'm going to use the cosine of 50 equals x over h, or h is 65. So I'm just going to do 65 times cosine of 50. And I get 41.78. It says to the nearest tenth, so 41.8. That's the x component. So if this was measured in miles, that would be 41.8 miles east. And then how far south did I have to go? Well, that's where I do the next one. I'll switch colors here. Y is opposite of 50. So I'm doing the sine of 50 equals y over 65. Multiply by 65. And I get 49.79, so 49.8. But notice that it's positive in your calculator. If you didn't type it in, try it. It doesn't give you a negative. You have to remember to put the negative in there. So negative 49.8. Let's again, miles, that'd be negative 49.8 miles south. All right, so it gives each individual direction, the east direction and the south direction. Okay, that's component form. Describe the vector using component form. Give each component to the nearest tenth. Again, let's look at the signs first. That's what I like to do first. The x, since it's in the third quadrant there, x is going to be negative, and y is going to be negative. So they're both going to have a negative with them. Now, I don't see a triangle drawn, but I can very easily draw one. Okay, there's my triangle. Now, my x is going to be in a little different spot. It's always the horizontal. So I'll do x in red. X is down here. And then y is over here. All right. I'm using that 21 degrees. So in this case, 21 degrees, x is opposite. Wait, I'm going to go red. X is opposite. And then the 371 is the magnitude. That's the hypotenuse again. So opposite over hypotenuse, sine of 21 equals x over 371. Multiply by 371. And I get 132.95 to the nearest tenth. That'd be 133.0. But you got to remember to put the negative in front. So negative 133.0. Now let's do y. In this case, y is adjacent to the 21. So I'm using cosine of 21 equals y over 371. So 371 cosine 21 is 346.4. And I need to remember to put the negative in front. So negative 346.4. Okay. And there you go. That is component form. That's taking it a vector where you have the magnitude and direction and giving it in component form. The next example looks at the opposite. I'm giving you the component form. You need to give me the magnitude and direction. And then I want the magnitude and direction, each the nearest whole number. So I highly recommend that you sketch your vector. And basically, you're just plotting a point. So -8, +15. So that's there. Okay. You know what? I'm going to draw that a little bit bigger so it's easier to see for you. So -8, +15, that's like up here. Okay. And we know that's the right angle. We know that this is 15. And we know that this is 8. We're looking for the magnitude Actually, I'm gonna put an M there for magnitude. And I'll use X for my degree. Well, what can I use to find the magnitude? Hopefully you see that that's Pythagorean theorem. So it's just 8 squared plus 15 squared equals M squared. So 64 plus 225 equals M squared. And 225 plus 64 is 289. Nice thing is you can actually type it in the calculator. You don't have to break it down. So square root of 289 is 17. So the magnitude is 17 exactly. The direction, got to go back to using trig. With that angle there that I'm looking at, I have the opposite and I have the adjacent. So I'm using tangent here. So the tangent of x equals 15 over 8. Inverse tangent. So inverse tangent of 15 divided by 8 gives me 61.9, so 62 degrees. But now you got to give the directions as well. So I'm on the west and I'm traveling north. So I'm traveling north of west. And that's your direction. All right. I'm gonna go ahead and clear all that. We'll do it again. Again, I'll sketch it. -12, -7. So -12, -7. So this is 12. This is 7. Notice I don't care about the signs at this point. Magnitude you're going to find, again, by doing Pythagorean theorem. This is why the negatives don't matter, because when I square them, it's going to become positive. And so I get 49 plus 144. 4 plus 49, 193. It's going to be 13 point something. 13.9. So it says to the nearest whole number. So we're going to say the magnitude is 14. So if I went to the nearest 10th, which I usually do the nearest 10th, it'd be 13.9, but I did say to the nearest whole. So I'm going to say magnitude is 14. Okay. To find the direction, I need to do the tangent again of x equals the opposite 7 over the adjacent 12. So it's the inverse tangent. And I get 30.2 or 30 degrees. And that's going to be south of west this time. Right. And so that's going the opposite way. That's giving you component form, and you give me the magnitude and direction. All right, a couple word problems here. They're not hard once you get them sketched. Barcelona, Spain is 207 kilometers north and 428 kilometers east of Madrid, Spain. On a direct line, how far is Barcelona from Madrid to the nearest kilometer? All right, so I'm just going to sketch it. So I'm going to put Madrid in the middle. So Madrid is in the middle. So Barcelona, Spain is 207 kilometers north. So that's up, and 428 kilometers east. Somewhere over here. Okay. So basically what I've just given you is the components. By the way, that's Barcelona. 207, and this is 428. How far are they apart? Well, we're going to do the Pythagorean theorem. 207 squared plus 428 squared equals m squared. So I'm just going to go straight to the calculator here. 207 squared plus 428 squared is 226,033. And I'm going to square root that. 475.4, so 475 kilometers. They're about 475 kilometers away from each other. Now I'm going to try and find the direction from Madrid to Barcelona. Again, tangent of x equals 207 over 428. So inverse tangent of that fraction. And I get 25.8. So we're going to say 26 degrees. And that's north of east. All right. Last one. A bird flies 73 feet in a straight line to a point that is 41 degrees west of north from its original nesting site. Give the bird's final nesting site in component form rounded to the nearest tenth. All right, so we are going to find 41 degrees west of north. So north is where I start, and I want to go west or left 41 degrees. So somewhere over here. Now that is this right here. That's 41. It goes in on that side. It doesn't go on the bottom. That would be north of west. West of north, the 41 goes right where I have it there in the picture. It's 73 feet in a straight line. That's the magnitude. And we want to find x and y. All right, so x is opposite 41. So sine of 41 equals x over 73. So 73 sine 41, I get 47.89 or 47.9. And now I'm jumping ahead of myself. I should have looked at the signs first. So x is going to be negative and y is going to be positive. So that's going to be negative 47.9. And now I'm going to find y, which is adjacent, and then the hypotenuse. So the cosine of 41 equals y over 73. 73 cosine 41 gives me 55.09 or 55.1. And that's positive in this one. Okay, so pretty much everything is either starting with magnitude and direction and finding component form, or starting in component form and going back to magnitude and direction. Hopefully that helped, and make sure you ask questions tomorrow.